you can see the after the pure carbon strength, you can see that sorry, the hybridization having a very good ultimate strength at the same time not degrading. You can see the glass and glass combination exhibiting 80% of tensile specific strength compared to the pure compound. In flax and carbon hybrid combination, the set 4 you can set the carbon the set 4 show that maximum tensile strength is 57 compared to the pure carbon. You can see that the tensile strength specific strength point of view, the ultimate strength point of view, that we want to be the best on our requirement. We can put a hybridization. The same time, we can see that this is one of the tensile strength and then tensile strength. The same time, you can see the vibration resistance. The vibration resistance is also steady. Initial steady before we actually implemented in our unmanned aircraft. You can see that we done a forced and free vibration test, electromagnetic shaker setup, and then you can see the frequency and amplitude results, and then you can see the below damping ratio of the vibration, various hybrid composite. You can see that set 6. It's kind of it's kind of the combination of the flax and carbon and flax having very good damping resistance, and then strength also not degraded much, and then same time the damping resistance improved, and then we are actually using the multi-copter, the cost also reduced, and then the damping resistance improved. This is the one kind of real time we improved structural hybrid composite structure of our multi-copter. The same you can do a stimulate and see that real-time condition in aircraft, and you can aware about the Airbus or Boeing. We want to ask aerospace standard FEM analysis. The standard will be there. We follow the standard machine and do a FEM analysis, and then do the results. Finally, the result factor is very important. We also done some study compared with the carbon, glass, and aluminum, the hybridization best results, and see and use the structures and see finally the resolve factor. The resolve factor is actually almost in aerospace industry. We actually follow 1.2, 1.1 is fine, and then almost the structure also used in the flax and carbon and flax. Also factor is the same for the model analysis and result, and then compared with the steel, you can say aluminum, and then stress develop high, and then low in the flax hybrid, and then see the different modes, and finally see the stress value and find out the resolve factor. And then this is the resolve factor, and then the stress, the RF value will be suitable for the hybridization. Then the second is the fixed wing spar, the fixed wing UAV spar section, and then the same material results we applied, and then the analysis point of view. Now we actually some of the structures were 2 hours endurance, and then for longer endurance we actually the Aerospace project, the government of India funded project, that is a pure carbon and then powered by the fuel cell. The structure majority of the component are the carbon fibers. Okay. Now the cost is a very important thing, and then now the production point of view we are working on that cost reduction point of view. At the same time, the strength we are not degrading, and then we are using for the applications. Okay. The thing 5-meter wingspan. This is before the we have done a lot of research, and this is one of the analysis result. A fixed wing UAV, different material, and then CFRP, and then hybrid composite, and you can see the resolve factor will be high. And then that's kind of it's not equal to the pure carbon, but the strength as per the requirement strength we are achieving, and then cost reduction also we are achieving. And then some interesting thing one of the project about the aircraft floorboard. I'm going to share it. It's kind of good. This is an aircraft floorboard, and then this is a floorboard. You can see that different panels will be there. Panel 1, 1A, and then panel 2, 3, 4. Different panels along with the fasteners. Okay, this is one of the things, the hybrid sandwich section. You can see that is a fastener location. And you can see that three different cases. Okay, this is a case A, case B, and C, D. I can see that the upper face and core, the face section and lower. That is a two-face section. Upper and lower have maintained a 5 mm thickness, and the core will be like 10 mm. Like that, different B, case B, case C, case D. And this with a unique load of 200 lb per feet square, and then material property of the aluminum of outer face, and then CFRP, so top and bottom face, and then AL052 for the honeycomb core section. Okay, this is a material property. The floor calculations, many of them are about that. This is follow that the floor rule. The final, the different panel 1 and panel different panel we seen at panel 1 and panel 1A and 2, 3 different panel, and finally the SO factor based on the ultimate the stress, applied stress and the stress, and then we finally see the SO factor for normal section and then the critical section. You can see that I come back again to the section. You also take normal section and then see the critical section. The critical section area, we have a lot of rows, and then the area will be less. We also do for critical section, and then we'll finally see the reserve factor. And weight also very important. At the same time, aluminum, and then if you use the core, the face will be aluminum 2024 and carbon. You can see the cost will be come down. The cost of stainless weight will be very less compared to the aluminum. And then you can see the with fastener, without fastener, what is the weight reduction, weight comparison of like different cases. This is a CFRP. And finally, the very important thing, these are the failure modes analysis, failure modes and hybrid composite material like face shielding, and then core shear, and then face sprinkling, and delamination. We actually taken the unit load and comparing the different combination, different cases. You can see the different combination, so factor values, normal cases, and then yield stress, and then linking stress, and then core shear stress. This is for AL2024 phase sheet, and then this is for the CFRP phase sheet. So this is for a panel 1, only one panel is shown here. This is for critical section. I mentioned that the panel 1 itself will take a critical section and analysis. That's very, very important in aerospace. We actually do for the critical section and see the resource factor value, then see that finally the structure is passing or failing. This is for the CFRP phase sheet. For a top and bottom. This is finally you can see that that face thickness based on sperm, the face yield happening, face wrinkling, post beds, the failure mode mapping based on results. This is the results and mapped the face thickness based on failure mode mapped for case A, B, and C, D. Finally, summarizing from the result, you can see that. And clearly it's seen that case A core shear stress occur in panel 4, 6, 7. In case C, the face, the phase sheet the failure occurred in panel 3, 4, 6, 7 for a specific load condition. In the case B, the upper thickness 3 mm, lower face thickness 3 mm, and core thickness 14 mm, and same for KST. I think you can compare with other all the things, the KST, the positive failure analysis, and then the 3 mm outer upper face thickness, lower face thickness 5 mm is causing our condition loads. Finally, the different combination of hybridization, thickness, and materials we can come across. This is one kind of project that we done a case study, and then come across. Now we are actually practical. We are working on coupon test, and then we are now and then finally submit to a customer or the aerospace customer for the aircraft, and then this will be like implemented into aerospace. This is one kind of the sandwich structures for aerospace composite. Also, the different the new research, new improvement, and then we also working on and then on the face and core, and then face the different combination, and then with the cost effective point of view, and then the strength point of view, we're working on that. And then coupon analysis based on the ASTM. This is a small analysis. The coupon analysis, the coupon carried out a small analysis as per ASTM D7250. As per there was standard machine carried out, and see the quality of the material, and here you follow the AM2036 mesh results for quality of the mesh. It's very important before going to apply for the boundary condition and seeing the final results. Okay, it's a material property for the analysis for aluminum 2024, the top and bottom face, and then CFRP top and bottom face, and finally see the AL5052 for the honeycomb structures, the material properties, and then formations. The boundary condition, uniform distributed load of 100 Newton is applied over the beam, which has simply supported a boundary condition. And then you see the maximum stress. This is the results. You can see that the RF value, maximum deformation 0.16 mm is absorbed near the pitch section. And the overall weight of the panel is AL phase sheet is 333 grams, and then you can see that 1 grams of CFRP. You can see the improvement in RF also, and then final results. And this is the improvement of the existing many Sikorsky different helicopters structures, aerospace and the aircraft. Many of the structures will be like honeycomb, and the core will be the aluminum. Now they're replacing the face section with carbon fiber. The hybrid sections are including the state. Still, the improvement is going on, and then the graphene, and then some hybridization of structures to improving, working on that. Okay. Finally, the production point of view, the industry application point of view, how do we can cost and then use the low cost and high strength material for aerospace application. Because already I mentioned about unmanned aerial vehicle. This unmanned aerial vehicle is a big thing. A lot of opportunity in a composite material, a new kind of material, and then improving the natural vibration resistant, and then impact resistant, and then apart from other basic tensile and flexural things. And then they play main role on composite. Okay, we have in-house autoclave. Okay, the cycle also very important, different cycle, and then pressure and temperature we want to maintain in autoclave. You also use the vacuum bag also, but in autoclave you see the different combination of cycle to improve the strength, and then finally the results and time, the cost also improve. That means the composite and advanced material of opportunity hybridization is a lot of opportunities there. I think the researchers here and proposers and scientists here, you work on an advanced material like hybridization, the problems of industrial issues, how to improve the strength, meanwhile, and then same the costing point of view. There's a lot of research. Okay, I think Virginia Tech, I mentioned about that. I think they are mainly working on graphene. Okay, how to implement the graphene, and the cost was very high in the graphene, and then the cost point of view also how to hybridization and using in structures and the graphic coated UAV. You've seen that, like that. Cost point of view, strength point of view, how can you use it in a real-time application? There's a lot of research is going on. Apart from aerospace, okay, if the automotive is one of the important area. Many structures in Audi, BMW, and many the Fiat Renault, and then Fiat Ford, the structures and many the doors, panels, hybridization materials and structures part, the composite, and then the main door. The future prospect, one interesting thing, another 4D printing. 4D printing object that transform itself into the other shape over the influence of the external energy input as a temperature, or light, other environmental stimuli. It is similar to the shape memory structure. This is one kind of futuristic prospect of materials for coming things. And then they mentioned about graphene. A lot of research is going on, study and publication. The research is going on in the act of itself, implementation of graphene, and some different applications. I think future the graphene, the combination of hybridization and coating or mixing the oxide, different combination for thermal resistance and STEM point of view improvement in all the areas. The composite graphene will play a major role. You can see this is the medical also. They are using graphene, biomedical field and electronics and energy for the battery, especially looking at graphene, and then other futuristic sensors also using on that. Just apart from this, okay, just you see that only 3 case studies, and then hybridization, the composite having a lot of opportunity. I think you can see that the combination of synthetic and natural fiber, different, based on the requirement. So what some people actually impact resistant, and the helmet, and then impact resistant structures. And they're using Kevlar hybridization. A lot of research and combination is going on. Okay. This is one of the key area, the composite having a future, and then next to the future, that hybridization material, improving the strength, same time the cost play a main role on that hybridization. Okay, and then apart from this 3 project and 3 case study, we seen it, and then some of a few interesting experience. My learning every time there's something doing learning. I used to tell that, okay, every time the new learning, that industry design analysis, and always the futuristic research work. It's very important, sustain in a field like aerospace. Like that, we also, in the composite, but in an autoclave combination, like sandwich structures. You can see them just sharing them from aerospace, UAV, unmanned aerial vehicle structures. Many other structures in aerospace, we've seen that, semi-monocoque structures. Nowadays, there's many of the structures. You can see them many drones, from South Korea, China, and the vertical VTOL UAVs. They have monocoque structures, and then hybridization monocoque structures have a very good property, and then strength, because the life is not that much important. And then there is very good the mini structure using hybridization, and then you can see that some of the section using the core will be foam, and then the face will be like oven fiber, and then improving the strength and structures and the fuselage, and being some of the area, the panels in material, the placement of fuel cell, battery, and they're using hybridization structures. These are the key areas. The prepaid materials also is they're using for the hybridization things. These are the lot more hybridization, the the strength improvement point of view, cost take improvement point of view is going on. There is a kind of and especially why I'm just spending more time on. We almost 4 years we into the unmanned aerial vehicle. We come across two different projects. One is amphibian unmanned aerial vehicle. We successfully tested in Korea as well as in India. We got a 2019 end Government of India for the Best Innovation Award for the project. That is a kind of amphibian project. That's application that requires different loading, and then it's kind of water resistant. The hybridization there is different. The overcraft is a structure. This combination of amphibians, combination of multi-copter and overcraft. You can see that the overcraft, the PDM chamber, and then the hull. You can see that sandwich structure. Okay, and then really good and water resistant. And we use the carbon and then aluminum core. Okay, face will be like carbon. This is the PDM, same, and hull also same, and then some of the pad thickness, and then placement of fibers, carbon is different. And then this is really the real-time application. We recently you've seen it, the November flood. Many of them are okay. The Chennai police, we supported our warcraft, okay, delivering the food to the flooded area in November this last 2 months before with that hybridization structure. I'm just saying that is playing main role of cost. We are reduced a lot cost, and then strength also is really good carrying the food. It's a kind of a one different amphibian vehicle, and then hybrid face is carbon and core is a honeycomb structure, and then once again face is the carbon. That is one project, successful hybridization real-time project. Then the second one is I mentioned about the 5 meter wingspan, 4.5 hour endurance, fixed wing VTOL, vertical takeoff and landing aircraft. This is also like we are working along with the Spanish partner. The Spanish partner is the Tier 1 to the Airbus. The key player, and they're working, and they're almost the project is successfully completed now. They almost in 150 hours from the aircraft, 5 meter wingspan, 400 hours endurance, like fuels and power. That's the usage. Some of the parts, some of the structures will be hybridization, and then carbon structure, carbon parts, and then you will see the booms, VTOL booms, hybridization structures. And this is the experience. We done an initial coupon level analysis, and then finally get a final workable model. Still, we are no reliability working on that. We have to fly 6 more months, and then we want to see that thousands hours of flying and see the reliability of the structure and data and other systems. Okay, we are working on that on different condition. We are actually following the FAA type certification because our factory in the US also. We are actually we are working on US standard to get a type certificate of an unmanned aerial vehicle. Then it will be you can commercially you can sell the product. That is very important. The material point of view in an unmanned aerial vehicle, the bigger drone also that they're following type certification. Type certification, all the material test is required, and finally got with that the research, unmanned aerial vehicle, lot of research in hybridization is happening. This is the recent project. A lot more project is going on, hybridization thing. This is the kind of I just share some experience, my learning. They keep on learning every step, new projects. Okay, and then finally I'll come to the final slide. Okay, the learning gives a creativity, and creativity then leads to thinking, and thinking provides you knowledge. Knowledge makes you great. The Kalam's quote. Finally, the early stage learning is very important. Doing the advanced material, the hybridization materials, very important for the aerospace application. This this is just my experience, and then some of the key the projects on hybridization. Once again, thank you, Hindustan, and then audience here. Any questions? I'm happy to answer, and then I can support it. And then if anything, I can also connect my colleagues, and then the research partners like Vijay and some other people. Thank you. Any other question and answer, I'm happy to share.
Thank you, sir. Thank you for the session and for your presentation. Uh, Audience, the participants, the session is open for you for the questionnaire session. You may either unmute your mic and ask the question directly to the resource person, Dr. Dinesh Manoharan, sir, or else you can type your questions in the chat box so that he can answer it. So we have a question, sir, from M. Magesh Kumar, that how do you overcome the disadvantages of natural fibers when it is incorporated with conventional fiber? You are not audible, sir. You have muted your mic. Excuse me, sir. Hello, sir. You have muted your mic. Hello, sir. You have muted your mic. It seems, sir, we couldn't be able to hear you. Sir, you have muted your mic. We cannot able to hear you. Yes, we couldn't able to hear you.
Able to hear? Hello? Hello?
Yes, sir, you're audible, sir.
Yes, thank you. Thank you. Thank you.
Yeah, audible. So you're audible.
Yes. Sorry, can you please tell me the question you're asking something? No, I'm not able to see in my.
Yes, sir. How do you overcome the disadvantages of natural fiber when it is incorporated with conventional fibers?
I think I mentioned no my the one of the problems issue with natural fiber like flax. So one combination I mentioned the flax fiber along with the synthetic fiber. We can improve the strength of the vibration damping resistant. The same time the strength, you can see the strength will be degraded. Okay, that's very important challenge for us. The composite, the structure that we want, the aerospace structures, the strength is important thing. The cost is not a matter because the strength is important, lightweight. Okay, that same we are doing the natural fiber combination based on the requirement used for the unmanned aerial vehicle. That it's kind of 40 kg, the 45 kg is the maximum takeoff weight. Okay, we use that. We actually solve the issue of the vibration resistant things, and at the same time the strength will be degraded. The 20% of the strength will be degraded. That will be acceptable structural limit for us for that particular application. The application to applications we can use for the natural fiber.
Okay,
Yes.
sir. Is there any other questions from the participants? You may please unmute your mic and you can raise your questions, or else you can drop your questions in the chat box. The session is open for you. Well, the questionnaire session is open for the participants. In case if you have any doubts, you may please raise your questions, either in the mic or else in the chat box. I think there are no more questions from the participants, sir. It seems.
Yes.
Okay, sir. Then, so thank you very much for the wonderful session, sir. We hope that the participants all around the country here, they have gained a lot of informations um, uh, and the techniques which involved in the hybridization. They have learned a lot of techniques. And we once again we thank you very much for accepting the invitation and being here with us for delivering this wonderful session. Thank you so much, sir. It's our pleasure to have you here.
Thank you once again. No, this engineering management team and then head of the department, and then especially thank you for that. Thank you for all the participants. It's very short, briefly explained about the experience on composite hybridization. I think we hope many of them understand that. I think a lot of opportunities are working on research activity, especially on hybridization composite, advanced composite. I think there is people here in the future. They really make it useful for the real-time application. That's very important for industrial point of view, like unmanned surface vehicle, unmanned aerial vehicle, and then advanced air mobility. A lot of opportunities there. And then once again, thank you, management, all of them, and all the best for all of them for the future research work. Thank you very much.
Thank you, sir. Thank you so much. Well, thank you, dear participants. The feedback link is in the chat box right now. You may enter your feedback. The feedback link will be automatically expired in an hour. So I request all of you to kindly post the feedback. And as we said earlier in the presentation, tomorrow's presentation is on, and we have two eminent personalities, those who are joining for us from abroad, actually. So, despite of the huge time difference and distance, they have accepted our invitation, and both of them are joining from abroad. So, one is Dr. Muthuram Prabhulanjalian from Purdue University, United States of America, for your morning session, and for the afternoon session, Dr. Satish Kumar Anushya Ponnuswamy from University of London, UK. And both of them are going to talk in the topic of artificial intelligence, the role of machine learning and artificial intelligence in the selection of materials, especially the composite materials. So we expect the maximum participation from your side. So we'd like to see the maximum participation for tomorrow's session. I hope you'll be available, and see you there. The feedback link is available in the chat box. Once again, kindly post your feedbacks, and see you tomorrow. Thank you.